Good morning. In the previous lecture, we have seen the RMS and average value of a trapezoidal signal. In this lecture, we will see the RMS and average value of a pure sinusoidal signal. In the figure which is there on the screen, you can see that this is a sinusoidal signal. Which generally has the form of Am sine omega t plus phi, where Am represents the peak value and omega represents the angular speed and phi represents the phase angle. So this is the generalized form of a sinusoidal signal. Now, if you see, this is a generalized form of a sinusoidal signal, and it consists of a positive half cycle and a negative half cycle, and one complete positive and negative half cycle will be treated as one full cycle, and it is considered as a time period. So you can see that the time period in this case is 0.02 seconds, isn't it? So when you do have the time period, you can write omega is equal to 2 pi by t, which is equal to 2 pi by 0.02, where pi value is 3.14. So if you solve it, you will get 314 as the omega value. Now, there is no phase difference. There is no phase difference from the reference point. The signal is starting at the origin itself. So in this case, phi is equal to 0. Let us suppose if the signal has started somewhere here, where this is the reference point, then this angle is treated as phase angle. But in this case, it is starting at 0. So I will take this one as phase angle as 0. Okay. And the peak value is 10. So I can write the equation as 10 sine omega is 314 into t plus 0 degrees. This is the representation of the sinusoidal signal. Now, once again, it can be treated as a periodic signal with a time period of 0.02 seconds. And the generalized expression is V of t is equal to capital V sine omega t plus phi, where omega is 314, phi is 0, and V, the peak value, is 10. So my equation is V of t is equal to 10 sine 314t, and this conduction time, if you carefully see, it is completely conducting from 0 to 0.02 in its very own fashion, a sinusoidal pattern. So my mathematical expression is this one. Okay. So once I have it, now I'll move on to determine the average value of the waveform. You know the average value of the waveform, it is 1 by t integral 0 to t v of t dt. So I can take, so I am taking the first sequence. So the time period is 1 by 0.02. This is the time period. And the conduction time 0 to 0.02 is the entire time for one cycle, which I am considering now. From 0 to 0.02, it is following the sinusoidal pattern. So I'll write the sinusoidal equation. This is 10 sine 314t. Right. So when I do the integration for this one, 10 remains outside. That is a constant term. For sine 314t, I'll get, see, for sine 80, the integration is minus cos 80 by a. Isn't it? So I can write it as minus 1 by a and take it outside, and I can write it as cos 8. So that's why here in this case a value is 314. So I have written 1 by 314, and the minus also I have written outside. So the remaining is cos 80, cos 314t, where t varies from 0 to 0.02. When t varies from 0 to, this is 0.02. So cos 314 into 0.02, sorry, this is 1 minus 1, okay. So its value is 1 minus 1, so its value is 0. Okay, so my average value of a true sinusoidal signal is 0. Now coming to RMS value of the waveform. You know the RMS value we have. This is the equation where t is 0.02 and conduction time when considering 0 to 0.2. I'm substituting the value of V of t, but I should square it, right? So when I go with the squaring, I'll get 10 square, it is 100, I have written outside. But whereas sine square 314, so I can't get the direct integral of this one. So I am using this expression. Sine square 80 is equal to 1 minus cos 280 by 2. So I am employing this particular formula here. So I'll get 1 minus cos, this is 62080 by 2. Okay, twice of this one. So I'll remove, see this is, I'll remove this 2 outside. So 100 by 0.02 and here 2 also will be coming outside. So it becomes 2500. The remaining is 1 minus cos 62080. For 1, the integral is t, whereas for cos t, the integral is sin t. For 628, I'll be getting here. Okay, so if you substitute it, you'll be getting a value of 7.07. The average value, we have already got it as 0, whereas for RMS value, its value is 7.07. And what is the peak value? The peak value is 10, isn't it? So, if you carefully see, what is my crest factor? Okay, see what is VRMS by V average? It is 7.07 by 10, which is equal to approximately 0.707. I can write it as 1 by root. Try to remember this one. The RMS value, sorry, this is max, right? VRMS value. So VRMS is 1 by root 2 times of V maximum value in case of a pure sinusoidal. I'll ask this bit for your examination. Okay. What is the value? What is the relation between RMS and maximum value of a pure sinusoidal wave? It is 1 by root 2. Okay. Now moving ahead. Now I hope that you are now able to determine the average and RMS value of trapezoidal and also a pure sinusoidal waveform, and try to solve these problems at home. This is a trapezoidal waveform and this is a sinusoidal waveform. Try to get the RMS and the average values. Thank you.